Hello everyone, I'm Stefan Birrer from Phenix, and today we're going to talk about our platform and how we deliver real-time video at scale. Our vision is to stream the Olympic opening ceremony to 1 billion people in a personalized fashion, where people can get content that is tailored to their interests, as well as in sync and in real time with other users. Our company was founded in 2013 in Chicago by myself and my partner Scott Puzzletiner, and we grew the company to today about 30 people with offices around the world in North America and Europe. We have delivered a number of firsts in our industry. For one, we delivered an autonomous platform that delivers real-time video on a global scale. We delivered first in-sync real-time video that allows our customers to broadcast video across the globe on many different devices in synchronous nature. We also deliver to a lot of concurrent viewers, over 1 million is possible. We use multiple cloud providers so that we can deliver high availability options. So in case there is an issue with a internet service provider or a region, or even like multiple region of a single vendor, we can sustain our services when we do that. Our technology is used to enable betting use cases. Because of the real-time nature, it enables in-game wagering on horse racing and greyhound. We also deliver sport content with multiple angles that allows viewers to see how the game unfolds from multiple directions at the same time. We also enable monetization strategies that allow our customer to monetize the content that they are giving to their end users. And we have become a partner of one of the largest media companies in the world. So some of the key metrics of our service is that we deliver in less than 500 milliseconds glass to glass from the feed from the camera out to the broadcast-sized audiences. That we synchronize the delivery of those videos in less than 100 milliseconds synchronization window. That we provide extremely fast time to first frame. As you can think of, like an e-commerce transaction, every second of latency reduces the transaction volume that you will be able to generate. We operate over 30 points of presence and data center location and serve millions of streams every day. So the key value propositions of Phenix is less than half a second end-to-end latency, broadcast size audiences, and synchronization of the viewing experience across multiple screens. We also offer a secure data channel that allows our customers to build new forms of interactive content. Here's an overview of like how our video workflow works at the high level. We take a video signal from a production center. That could be a camera, it could be in very simple cases a webcam like in this broadcast, or it can be a professional produced video feed from a stadium. It goes over our encoder in real time, sent out to our network, is distributed across the globe, and then distributed to the end users using a WebRTC compliant implementation that we call the Phenix Interactive Transfer Protocol. And all this in less than half a second's end-to-end latency. Below we compare it in kind of the traditional use case where HLS or Dash is used to package the content and distribute it using a traditional CDN and then deliver to the last mile, typically resulting in latencies from 10 to 30 plus seconds. So our autonomous real-time network, one thing that probably will be surprising to most is that despite that we run more than 30 data centers, we have 0 operation people. Our platform is fully autonomous, so we subscribe to a philosophy of 0 ops, which means no operating staff, no human supervisors of the platform. The design and the architecture, as we're going to talk in a bit, is from the ground up designed for high availability. So we want to make sure that failures the system will be able to overcome any sort of failures at the micro and the macro scale. For that, the system monitors itself constantly, over 10,000 health checks per second. It heals itself, so if it detects resources that are not performing to specification, they will be retired and replaced. It also scales itself. By monitoring, it also knows kind of the load. At the current level, it has a sense of prediction for the near-term future, and it uses that information to scale itself, and it protects itself. So if there is unexpected low conditions, it will also be able to respond to that and add additional resources as needed, or replace resources that basically are deemed unhealthy. Fundamental to our technical approach is also our engineering approach, because one goes hand in hand with the other. Wouldn't be able to do what we're doing without our engineering approach, and without our engineering approach we wouldn't be able to deliver on our goals in the technical side. So one thing that we set out to is kind of define what is the way of the special forces for engineering. We emphasize strongly on individual contribution, where one engineer is going to be responsible for the functioning of a deliverable piece that they own from end to end, but doing so in a very transparent way. There is a declaration, we have mission statements, success criteria, there is peer review across the process, constant updates of problems, thought process, decisions, and announcement of completion. So everything is up for, in essence, challenge, and we basically learn and iterate, use the collective know-how at every stage to optimize the solution and end up with a result that is repeatable. And it doesn't necessarily mean one engineer will be able to produce a better than other. So everyone should be able to produce at the high level, because they can leverage the collective know-how, even though they are the individual contributor on a certain piece of work. We apply a lot of principle, but ultimately are very pragmatic, right? If all in the end has to work. If it doesn't work, it doesn't matter how many principles we followed. We're a strong believer in QA automation. We have several thousand of acceptance tests that constantly run against our platform. So when a feature gets into staging environment, it will go through a process where it is vetted against this automation and acceptance testing continuously. Then we can do staged rollouts where, with our presence around the globe, we can use a certain subset of the volume, even randomized, to leverage a new feature or an improvement and validate that it actually works the way it should. Here's an overview of how our architecture looks. At the high level, it's a microservice architecture. Maybe not necessarily exactly like some folks are used, but the gist is we have a messaging bus that connects basically everything. All our modules are connected through that bus using a well-defined protobuf implementation interface. And that allows us to create kind of a versioning of APIs as well as maintain forward and backwards compatibility when we roll out multiple versions for a limited period of time. The key components, obviously, we do have endpoints on the HTTP, which we leverage, some third-party services, which we're going to talk in a bit. We have front end, so we separate termination of requests coming in from the internet, being it HTTP or WebSocket. We have services instances that allow us to implement workflows for business logic. We have streaming infrastructure that allows us to deliver a large amount of data to a lot of users. So you see, like, from the thickness of the arrows is kind of where the internet traffic is, whereas HTTP is more of control traffic, and the streaming workload is a WebRTC compliant protocol. We have caching infrastructure where we can cache certain kind of artifacts, for example, a recording of video for replays. We have a key value store that's a memory-based implementation for state. So one of the key aspects of our design is that the state lives in a memory-only implementation, as so-called the brain, and all the services that operate on that state that can scale out horizontally will use that state and will not keep any local memory to store essential state of the system. There's some caching, but no, all the true state is in the memory. And this is replicated across multiple POPs, which all are connected through the MQ bus. So we have three highly Phenix-specific components. That's basically the front-end termination, where we take HTTP requests and translate them to internal API requests, and they're routed then to the right, either an Anycast location or a specific node for the response. That happens through the messaging bus. We have the services cluster, which runs a number of microservices, which may be different to what you're used to. Like microservice for us is a logical separation foremost. We can split it up easily into multiple clusters, but there's an operation overhead of doing that. And so we run a number of microservices in the same physical process, but isolate them against each other with request rate limiting and so on. And then we have a streaming cluster, and that's obviously where most of our effort goes in. We build a real-time routing network, right? That's based on C++ implementation, standard compliant, but built on with additional proprietary algorithms and improvements that enables our ability to deliver the lowest latency possible across large geographic regions. We also leverage open source components for where we can drive a lot of value without necessarily having to invest our time. Obviously, caching is one. There's a lot of great products for out of that, like Memcache. The messaging bus, a number of messaging bus out there. Like we use AMPQ API, so that it could theoretically be replaced with different implementation. Our favorite is RabbitMQ, has proven itself very scalable, very performant over the years. For key value store, we use Aerospike in a memory-only mode without any disk activity. Even though they're super fast with SSD, we just leverage memory only to make it as fast as it's physically possible. On the streaming nodes, we also leverage some open source tools like FFmpeg. I mean, it's converting different content for let's say HLS and Dash delivery. We have our technology to write this out in real time, and then converting formats, for example, from HLS to Dash is something that we can leverage open source tools very easily without having to spend our time to support another protocol directly. So what we talked about so far is kind of the core of our platform. It's also because we are committed to high availability, we actually never want to depend on a third-party vendor or a third-party service in any of our mission-critical workflows. So all what you're seeing here are, some of them are in a mission-critical workflow, but they're in our deployment, configuration deployment, in such a way that there is a failover mechanism to another means. So we never have a problem where we depend on another service to be online in order for us to deliver on all our mission-critical services. But there are certain things that we leverage, obviously, for storage. We store billions of artifacts every month for video recordings, and so we use Google Cloud Storage for that currently. We have need for analytics, a lot of reporting. So the state is persisted in BigQuery, which is a pure SQL interface. So I like generically simple interfaces that are time tested, like SQL is one of them, right? So I don't necessarily mind using an implementation like BigQuery. It's extremely scalable and cost effective, and if someone knows SQL, will be able to use our BigQuery data and create some amazing big data analysis within a matter of minutes. We store several terabytes of BigQuery data a month. We use a third-party monitoring service for our components in mostly a basic fashion, right? We have like some custom metrics, but the amount of data that we collect is staggering. So typically it becomes cost prohibitive to use some third-party vendors at some point. So we have to kind of keep it minimalistic. We use file storage and data storage Firestore and data store to store certain other records, some of them are redundant, and also Firestore mostly for VOD, so that we keep a record of all the recordings that took place in a way that we can query quickly. When you say query, obviously in all the mission critical workflows, we typically do primary key queries. There's not like a select star where X larger 5 type of query in our mission critical, because there is no real-time nature to answering such a query. We also leverage Google Cloud CDM for scale, even though workload for us is only a small HLS and Dash is only a small percentage of our overall load. We move petabytes of data in real time every month. There's an aspect of like how our architecture scales, both inside a data center where these clusters each are scaling out horizontally based on real-time metrics that we collect and feed into our autoscaler, and it makes its intelligence decisions on how many instances of each it needs to run. We also scale horizontally at the macro scale, at the point of presence level, where we run n points of presence, and each of them is capable of delivering the full service. And they work together, connected to our backbone during redundant fiber connections, being able to access any stream in the world from anywhere else, and deliver that in very low latency then from their edge in kind of using the streaming servers to the end users using a very short round trip time on the last mile. And each of those data centers is basically designed, as we discussed before. They have their own state. Some of the state we mirror, so there is a very low latency across the globe when that state is needed to be accessed, depending on the kind of the requirements on how fresh a state needs to be. It's part of our ways. We don't necessarily want to have a strong transactional model. We don't sell. We're not a bank. But what we really need is something that's really fast, right? And has this healing property to always go to the correct state. So that gives us a little bit an ability to use some advanced, kind of pragmatic approaches in how we manage our state across the globe. So with this real-time network that on a global scale, it enables a couple of new use cases. Like one is the ability to deliver one channel to many users, as you can have figured by our broadcast size audiences. We also support group applications where we have a few people stream to a few more. Fan Connect, where you have a few people stream to a lot. So there could be, kind of the new stadium experiences where people sit at home and then it's broadcasted to a lot of people. Because of our ability to scale, without necessarily having to know how much load is coming on the system, we can support scalable inches. That means we could have, some people publishing thousands of channels into our platform, and we can dynamically size the number of instances that we need to run to support that use case. With the low latency and synchronization, we support multi-angle content, so you can have them synced, and virtual couch experiences where you have a few people together communicating with each other, interacting with each other, and watching the same game at the same time, right? And not everyone sees the score at the same time. It's a very important aspect of that. It can be used in the multiple markets. We support sports use cases, betting, trivia, where people can answer questions to win money, esports, low latency is essential, auctions, e-commerce, where people buy goods online, entertainment itself, or social applications. It's kind of like some of the key differentiator to traditional live streaming. So we can provide in-game contest opportunities. You can watch things with friends, multiple angles in synchronization. Can do all kinds of interactive experiences that really add value, differentiation to your products, and obviously reach the broadcast size audiences, and all this while streaming in less than half a second end to end. So here's an example of a virtual couch experience where we have multiple user-generated feeds coming into our cloud. They can be anywhere in the world, right? And then we have like a professional feed coming from the stadium that goes through a Phenix encoder that provides real-time multi-bit rate encoding that can be distributed to many people and provide an adaptive video experience. It goes in our platform. does the magic, right? It scales it, it makes it available on the edges where we need, and then you can basically build an app where you consume both the broadcast feed and the virtual couch experience of the users, and have that all in sync and in real time. Multi-angle, in a multi-angle case, you may have like people in a stadium, obviously broadcasting feed out of the stadium, the same content, multiple camera angles going in our cloud. They have people maybe in the stadium or out the stadium using 5G, other network connections, and we provide the adaptive bitrate technology. Everyone gets the best quality on their device given their internet connectivity. In this case, 5 camera angles. We did multiple more camera angles in some very high-profile events. From a workflow perspective, obviously the ecosystem is so rich, and there's a lot of integration points. I was talking about the pure real-time, less than half a second end-to-end workflow quite a lot. We support other means of for ingest in the stadium, from hardware SDI inputs, from MPEG-TS multicast feed in data centers, or RTMP ingests that go then through kind of our contribution encoding, or potentially some third-party RTMP contribution, comes in our platform, and then is delivered in our network using our global fiber backbone, redundant global fiber backbone. We offer some transformation, right? So you can convert content from real time into live HLS dash. We can use that for replays, so people can do instant replays on a multi-angle experience, and distribute it then on the edge, typically WebRTC compliant in the most volume, but also other protocols like HLS dash, RTMP, to basically every kind of client, supporting legacy use cases for enterprises with IE and so on. So some of our customers include betting customers. RMG starts to perform, which we stream horse racing, mostly in the UK, but also a global audience. CIS, similar, has a lot of greyhound races across the globe, almost 24/7, and customers all over the world. In the entertainment space, we hosted companion shows for ABC and Sony, where people could win hundreds of thousands of dollars answering questions in real time and participating in a game. We also streamed behind-the-scenes footage from the Oscars, which allow people to engage in a new way with an existing format, and doing so in less than half a second screen latency. Yeah, sum it up, it's like the 3 big values of Phenix is real-time, in sync, at scale. We were the first autonomous real-time network in the world. We have a strong emphasis on the zero operation paradigm. We're building the special forces of engineering to deliver on our high aspirations. We use a distributed microservice architecture to deliver our platform, and being able to innovate quickly enough without slowing down on maintenance. When we built the platform, performance, high availability, and all these very important goals were there from the day one, right? We didn't start building something that worked and then try to make it high available. We figured, like, this is how we need to build it if we want to make it high available. And last but not least, performance is not everything. It's the only thing, right? Half a second end-to-end latency. Thank you very much.
Thank you, Stefan. So very impressive latency. I think with our YouTube setup, we have around 10 seconds or 10 to 15 seconds. Maybe we need to improve for the Cloudflare game. Maybe that's something that could be used with your solution to get better. Are there any questions from the speakers here? Maybe?
You said like you have predictive scaling or something like magic. KI, it scales up, it knows what's coming. So how does it know what's coming?
Well, so you can basically the second and third order derivative of our performance indicator, So you look at like we track, for example, every user that connects to our platform. We know what the request rate is right now. We know how it develops over the last 30 seconds, and we can when you think about, like, you know, a bad example, but it's probably very much. And you look at those COVID waves. It's very easy to see that we are increasing and that it's not slowing down. And so that's when you do the derivative of that function, you will see that there's actually like an increase per rate per second, and that is a very strong indication that we are not peaked yet, right? And so that's one of the ways that it uses to create an indicator that tells it, well, I'm growing at this rate and I probably need this much capacity in 30 seconds or 1 minute. Obviously, the second piece of this, obviously, is our ability to scale extremely fast, right? It takes a lot less than 30 seconds for us to make an API call until we get a fully operational server in our platform. So that's another part of our innovation where we, in essence, basic essentialism. I didn't talk too much about that, but you know, we don't use too many frameworks for the key part, because you know, if you show me the scalable solution that can scale, or the off-the-shelf solution that scales from 1 server to 1,000 in less than 30 seconds, I'm definitely interested, but that's what we built.
I mean, yeah, we are using Azure, and if I need an additional server in Azure, it takes, I don't know, a minute, 2 minutes, 5 minutes until this server is online. And you also use, I don't think Google or Amazon is much faster than that.
I mean, my performance now, I mean, look, so all the cloud providers do some optimization. So if you just request the first type of server, that's a different story. But we do this a lot of times a day, and they do also smart things underneath the cover and doing faster. So for one thing, we obviously do, we have, you know, it's a container first architecture, but it's only one container. So all these machines are bootstrapping from the same container. So every single cloud region that we run in has already those instances running. And what happens is those images are therefore in the local cache of that zone. So when we make that request, that part is already pre-cached, right? And then I think just from the volume, I mean, there is probably some other optimization. So if you just request one server, or you know, very unregularly, or don't have running, then these caches will not be as warm as ours, because we do this thousands of times a day. So they're typically, you know, there's some differences between regions, but in the ones where we have a hot usage, the days, it's response time from API to server booting up is it's typically less than 15 seconds.
So what do you say to Tom about zero DevOps?
What's the question?
You say zero DevOps, and we're in a DevOps company. So.
Well, I mean, you know, it depends on the use case, right? But I mean, there is obviously DevOps that operations that takes place in that infrastructure layer, right? We just don't want to own that piece. And the other thing is that we focus on very basic APIs, right? So like the APIs we use for Cloud and for our mission critical workflows are create, destroy, or provision, start, stop, depending on the use case, right? What's the fastest one? It's not the same. So you're actually right with the Azure case. Like actually our integration, we have an integration with Azure too. So we actually pre-provision the servers and have them sitting in stop state, and we start them up because that's faster than provisioning them from scratch. But that's not the case for every cloud provider. So we figure out which one is the fastest, and that's like there's basically two methods, and we use the faster one. Then we work with them to optimize it. So that's kind of like our typical way of life. And but yeah, the like for us, like we want that to be, you know, like it would be very prohibitive to our business if our engineers would have to know all these cloud specifics, API and behavior, right? I think we want to just use the basic essentials, so that when we go on provider A or we go on provider B, I don't have to train my people to understand the difference. Now there is a little bit of that, let's say the logging interface or some nuance, like, I mean, but I do believe, like, fundamentally, like, since we don't have operations people, we have engineers, so they should be capable enough to open up the UI and figure out how to start the server or how that works, even though they never have to really do it manually, but just that kind of that type of level of operation should be able to do that, right, without having to get a certification in vendor-specific APIs, right? But yeah, it's would not scale for like our team if I had to have them, know all these vendor-specific APIs.
Also, thank you very much. Maybe we have still some work to do to do zero ops everywhere, and platforms are changing, so that's good to know that maybe there's still some work left. Okay, thank you very much, Stefan. So we move over now to Uwe from Cloudflare to do the quiz. So give us a few seconds to prepare that.